Okay, so 2-1 quadratic functions and models. This is again a review. I told you last year that last year is a total like prequel to first semester of this year, and it is. Every single thing we do this first semester, you have seen last year. Everything. So it's kind of nice. It makes this year a little bit less stressful. So we need to write these in standard form, otherwise known as vertex form. So vertex form is y equals a x minus h squared plus k. Okay, so we need to do a process that is called completing the square, which we did do last year a little bit, and so we're going to continue with it. So when we complete the square, we have to kick out the constant. Remember doing that? Maybe not yet. Okay, kick out the constant, and your leading coefficient has to be 1. So I've kicked out the constant, and so these two are the only two things I have left in my world right this second. And that has to be 1. So that means I have to factor out negative 1/2. If it needs to be 1, I have to factor out negative 1/2. Everyone see that? Okay. So if I do that, then I have x squared minus, well, half of 6 is 3, right? Everyone following what's going on so far?
Yeah.
Okay. So now we got the work to do. We have x squared minus 3x. I'm going to leave you a spot here. So you take half of this and square it. So we're going to leave it a fraction. Got me? Okay, so half of 3 is 3/2. And when we square it, we get 9/4. Now, in order to not change a function, like if I just add 9/4 into this function, did I change it? Yeah. I added, what's the only number I can add without not 0? So I added in 9/4, so I need to also subtract 9/4. Okay, so minus 9/4. But I want us to look here. What did I have out in front of here? Negative 1/2. So if I brought the 9/4 out, I'm really bringing 9/4 out times negative 1/2.
Times?
Yep, because doesn't this distribute in? Okay, so I just put negative 1/2 behind it. So it looks like I have a mess, but it's going to look really neat here in a second. So what we do now is we factor this right here. And you're going, oh my gosh, I don't want to factor that. That's the hardest thing I've ever done in my life. But there's a reason that I left this right here. Because this is called completing the square. We just made a perfect square trinomial. X minus 3 times x minus 3. We just made that. And so we have negative 1/2, because that's where it started. And we have x. And whatever this sign is right here goes next. So that's negative, so it's going to be negative. And this right here and then squared. If I factored x squared minus 3x plus 9/4, I would get x minus 3/2 times x minus 3/2. Okay, now I got to combine this stuff over here. Well, that gives me positive 9/8, correct? So this would be negative 80 over 8. So it's negative 71 over 8.
How'd you get 80?
Common denominators, because it was over 1. So we just wrote this in standard form, otherwise known as vertex form. So this is a parabola that goes right 3/2 and down negative 71 over 8, which is almost 9, right? And it is reflected, and it is wider than the parent function. So from that, could we graph a decent looking graph? Yeah.
Are they all going to be that?
Complicated?
Yeah.
No. Because the next one, the only thing that really made this complicated was the 1/2 in the front, yes. And what made it look horrible is the 3/2. Okay, so we're going to do the same thing. So x equals negative y squared minus 16y minus 58. I'm pretty sure that should have been y, but we're going to just treat it like it is. Okay? So the first thing is I kick out that negative 58. And I tend not to use so many steps. I'll show you how I do it. I just leave a bigger gap here. I'm going to have to factor out a negative 1 this time, right? That's easy. Factor out your negative. So that would give me y squared plus 16y. So then 16 divided by 2 squared. What is 16 divided by 2?
What'd you make the 2?
Because that's what it is. It's always divided by 2.
So plus 8.
So plus 8. So I'd have to minus 8 on the outside. Because plus and minus gives me 0. But I also have to multiply it by that negative 1. Because I pulled it out. So negative y, whatever this sign is. So plus. Oh, wait. I went with negative 8. What did you forget to do, and what did I forget to catch? Not 8. 16 divided by 2 squared, so it's 64. So subtract 64, but you're multiplying it by negative 1, so it's not minus anymore, it's add 64. Okay, so now plus, and then it's just this 16 divided by 2, which is 8.
Mm-hmm.
Now, this one's easy to see. If I come back up here, guys, what are the factors of 64 that add to 16?
8.
8 and 8, right? So now do you see why it would be the y plus 8 times y plus 8? Okay, now 58 plus 64 would be positive 6. Okay, so it's a vertex that's reflected over the x. Vertex. It's a parabola that's reflected over the x, correct?
Isn't it 58 minus 6? Oh wait, is it negative 58? Sorry.
That's okay. And it's the same width as the parent function. It goes left 8 and up 6. Again, could you graph something decent using that?
Mhm.
Yes. I will tell you that completing the square can be used to like solve for y. You would subtract the 6 over and then multiply by negative. So you'd have y plus 8 equals 6 squared. And then you take the what on both sides? Square root.
Mhm.
So y would equal,
That's 6, not
oh,
8.
the square root is 6 minus 8. Okay. But I will tell you right now, I never in my life used completing the square for anything other than writing it in vertex form. Other than when a teacher said, do it for this. It's not something that you immediately go to. And no, they're not all, you don't always have something to factor out, but I wanted you to have to factor that out twice because it has to be a 1. Okay? Okay, real quick definition of quadratic. You know this. It is ax squared plus bx plus c. Yes? You know that's a quadratic? You know it has an axis of symmetry that runs through the vertex. Don't you?
Mm-hmm.
Okay. You know that A is positive if it opens up. You know A is negative if it opens down. We know that. Okay, this is where I am going to stop. Now, your assignment will be up on Classroom. It's already up in Classroom, okay? Next hour, I'll have the assignment made. Get as far as you can, and we'll finish notes tomorrow.
Okay.
Got me?
Yep.
I was hoping only to get like the completing the square stuff for tomorrow.
Okay.
Okay, so